Good afternoon, ma'am.
So, I assigned 2 questions yesterday. Do you have any problem in that questions? Because the procedure is same, the part is the calculation part will take time, and we do not have so much lectures to cover up the syllabus. Only 4 to 5 lectures I think we have now. 1, 2, 3, 4, 5. 5 lectures we have. So because next week we do not have lectures, so I want to finish the syllabus. If you have any doubt, I will upload the material today. Okay, if you have any doubt in Bessel's equation and Legendre's equation, only the calculation is there. Okay, the basic idea you know already. You go through the solution, and if you face any difficulty, you can ask. Today, I want to start that your module 6 Z transform. Okay, so let's start Z transforms. Wait for a minute. So Z transforms. See, what does mean by Z transform? Oh, why do we need Z transforms? Like, see, we have Fourier series. Okay, then we have Fourier transforms. So Fourier transform means when we have the time dependent continuous function and you want to change the domain of the function to the frequency domain, frequency based function, then we use Fourier transform. But when we have the discrete function, okay, so for the discrete function we use Z transform. So for Z transform means Z transform to transform the time dependent function to the frequency based function. This is also the same type of like Fourier series. In Fourier series we have the function which is like for the function when we have the continuous function also. Already we have discussed in one class when in module 1, like the function is continuous or continuous in subintervals. So for the continuous functions, we have done with the Fourier series. Fourier series again, it is containing this, and Fourier transforms for the continuous function. So for the continuous function, we use integral, and for the discrete functions, we use summation. Okay, so Z transform means for the discrete function we'll define. Discrete means for the discrete values of n, like for n is equals to 0, 1, 2, 3, discrete values of n. Okay, and the Fourier transform, a function which is defined on a closed interval 0, 1 and continues. Means for each point between 0 and 1, the function was defined. Okay, function was continuous. And here, function is defined on these points, discrete points, 0, 1, 2, 3, not in an interval of infinite length. Then, if the function un Function means basically we have the sequence is defined for discrete values n is equals to 0, 1, 2 and so on, and un is 0 for n negative. If you will take the negative value of n, un is 0. Then its Z transform is defined to be Z transform of un is, see, I'll write here, Z transform of un, a sequence summation n is equals to 0 to infinity and infinite series, the same un I'll write here, and Z power n. Z power n, that means this summation you will get, because Z is variable here, right? So once you solve this summation, this series, you will get a function of Z, small z, capital Z represents a Z transform, small z the variable. Okay, so you will get a function. That function is represented by capital U of small z. Okay, if you solve this series, you will get a function in terms of Z, small z. Now, provided that this series, infinite series, right? But the sum should be finite, less than infinity, means it should converge. So when a series converge, when its value, when you take the sum and the sum is less than infinite. Infinite means a finite value. Then it will be converge. Means when it converges, then only this you can find the Z transform of un. Okay, so basically Z transform of any sequence un is uz. In the same manner, we can define inverse Z transform, that is un will be inverse Z transform of uz. Okay, so let's see. First, we need to remember the formulas. Z transform of a power n. A power n means like 2 power n, 3 power n, where a is any constant, any you can say that real number, even minus 2 power n, like you need to find Z transform of minus 2 power n. N cannot be negative, but this a can be negative, right? Because a. Now, by direct formula, Z over Z minus a. So a value is minus 2, so you will get 2. See, this is capital Z, Z transform of minus 2 power n is Z over Z plus 2. So how? By this formula. And from where you got this formula, let's prove this. Z transform of a power n, we need to find. So use the definition. N is equals to 0 to infinity. Un means a power n divided by Z power n. Okay, so first term a power 0, Z power 0, that means 1. Second term a power 1, Z power 1. Third term a power 2, Z power 2. Right? So you can write in this form up to infinite. Now this is GP, right? Geometrical progression. Sum up to infinite. So what is the sum for GP? A over 1 minus R, where A is the first term of the series, R is the common ratio. So first term of the series is 1, common ratio is A by Z. So 1 minus A by Z, that is 1 over Z minus A into Z. This. Okay, so Z transform of A power n is this. From this itself, you can conclude that Z power, suppose you have 2 power n, so Z over Z minus 2. Z transform of 3 power n, that means Z over Z minus 3. Okay, so remember this formula, and if you do not remember, then use the definition and you can find this. Now next is, next formula, we have Z transform of n power p, where n is non-negative, right? And p is a positive integer. So Z transform of np is equals to this. So let's try to prove this. like Z transform of you want to find n square. Just first I will give you an example. N square means, so minus Z according to this formula, d by dz and Z transform of n, right? So suppose we have Z transform of n, so simply we'll just take a derivative and then multiply by minus Z, you will get the Z transform of n square. But before that we need this, right? So first we'll prove this. Let's take Z transform of NP. NP means NP into Z power minus n, right? Because Z is independent of n, you can take one Z outside because there is Z outside. So we'll move accordingly. Take one Z outside, right? You can write n p minus 1 into n, right? And Z power minus n minus 1 because 1 Z we have taken outside. So minus 1 this, correct? Now if I write Z transform of n power p minus 1, you will get n power p minus 1 and Z power minus n, right? So please remember this, but I am proceeding from here itself. If I'll take d by dz of Z power minus n, yeah. If I'll take d by dz of this, let's take minus. Now balance this. See, minus n, so minus is there, n is there, and minus n minus 1, so minus n plus 1. So this term is same as this term, right? If you just simply take, okay, I'll show you. Minus z is outside. So minus n, Z power minus n minus 1. See this and minus minus plus. Derivative of this. So this and this term is same, right? So I have rewritten this term in this form, right? So now because differential operator is means differentiation of any discrete function is term by term differentiation, so we can take this outside. Minus z d by dz summation, because summation is, see, it is on n, not on z, so we can take d by dz outside, it will not affect this. N power p minus 1 and z power minus n, right? See this is the formula for Z transform of n power p minus 1. Z transform of n power p minus 1. Okay, and LHS was this Z transform of n power, right? So we have proved this formula. Okay, you no need to prove the formula, but you should know the formula. Now, first question. See the proofs I will not upload, so see the proofs carefully. Z transform of 1. You first method I'll tell you, means you can say that 1 power n, right? 1 power n is again 1. Just hold for a minute. So means a power n formula. So z over z minus a. A is 1 here. Simple. Now let us use another one, like what we have used. This, what we have proved moment back. No, because it's p is a positive integer, then I have to take negative. No, we can use that formula itself. But if you don't remember the formula, directly use definition. Un is 1 over z power n, right? So this is your another method. First term is n is equals to 0, so 1 plus 1 by z plus 1 by z square plus 1 by z cube and up to infinite. Again GP with common ratio 1 by z, first term over 1 minus 1 by z. That means z over z minus 1. See this and this. Same. Now let's find with this z transform of n. Now here we use that formula. N power p minus z d by dz of z transform of n power p minus 1, right? So n power p is 1 here, right? That means minus z d by dz z transform of p minus 1, that is p minus 1 minus z d by dz of z transform of n power 0, that means 1. Now you can use this formula, right? Now derivative of this, minus z outside, z minus 1 whole square, denominator whole square, denominator same, numerator differentiation 1 minus z and its differentiation again 1. Okay, so it is multiplied by minus z outside, z minus 1 minus z, right? Minus z was outside and z minus 1 minus minus plus, so z over z minus 1 whole square. Okay, so z transform of n is z over z minus 1 whole square. You need to remember this. Every time we are not going to prove this. So z transform of n is z over z minus 1 whole square. Now z transform of n square, same, minus z d by dz, z transform of n, right? Minus z d by dz and z transform of n is z over z minus 1 whole square. Now you can solve this. So to prove this is your homework. Okay, so means simply you need to take the derivative. The result you will get for n square, use it for n cube. So these were the formulas. Next we have linearity property. Linearity means like z transform. This is an operator which transforming a sequence to the function. Okay, but means it's like an operator. Okay, like we have differential operator, integral operator, And now this is Z transform operator. So operator means linearity property. Suppose T is an operator, right? And T is applying on this Ax plus By, where X and Y are the variables, A and B are the scalars. So linear operator means if it satisfies this property, ATX, ATY, BTY. Similarly, Z transform is also a linear operator. Now, X and Y was the variable for T operator. Now here we have variables like UN and Bn sequences, Wn. So A and B, C are the scalars. Why we have taken negative means we are just proving for negative also. So we have included everything in this. So Z transform of AUN, B plus BBN minus CWN is equals to this. Take A outside and Z transform of UN, B outside and Z transform of UN, C outside and Z transform of WN. If you want, you can prove it. Consider this as a complete sequence up to here. This Z power minus N, multiply Z power minus N in each term. Take, because A is independent of N, so you can take outside, B outside, C outside. This is the formula of Z transform of UN, Z transform of Vn, Z transform of Wn. So it is your linearity property. Damping rule, important rule. Many times we are going to use in this standard results. Z transform of UN means you will get a function of Z, right? Then if this UN is multiplied with A power minus N, where A is any scalar and see, we know UZ, we know UN, right? But if UN is multiplied with some negative power of N, negative power of A, right? Then this UZ means suppose Z over Z minus a function of Z, right? Then this Z, this small z will be replaced by AZ. When it is a negative power, AZ. When it is positive power, then this Z will replace by Z over. I'm saying that replace by. Okay, let's see. First one, Z transform of N, A power N, AZ over Z minus A whole square. Now see, to use damping rule, this N is multiplied with positive power of N. Okay, so see it carefully. We know Z transform of N, Z over Z minus 1 whole square, just before we proved, right? Now this is UZ. See, UZ. So we know UZ. It is Z over Z minus 1 whole square. Now it is multiplied with A power N. Okay, that means this, if it is multiplied with positive power of N, then Z will replace by Z by A. That means Z by A, Z by A minus 1 whole square. Wherever you will have Z in this function, replace it by Z by A. Okay, that means Z by A, Z minus A whole square and A square. Z minus A whole square. Yeah. So ZA, Z minus A whole square. Proved. Right? Similarly, use Zn square formula here. I think it is Z plus Z square over cube. Let me check. Z square plus Z over Z minus 1 whole cube. Yes. Okay. Z square plus Z over Z minus 1 whole cube and square. Right? To prove this. Now it is UZ. It is multiplied with positive power of N. So we'll replace this z by a whole square and cube. So you will get this formula. Okay. Now these z cosine theta, z sine and theta, these two we'll discuss in next class. Any doubt in this? Five plus. Any doubts? Okay then. Everybody please mark your attendance. So please remember Friday there will be a quiz at 7:30 p.m. First modules.
Excuse me, ma'am.
Yes.
Can you repeat the syllabus of the course?
Sorry.
Can you repeat the syllabus of the course?
First four modules.
Thank you, ma'am.
Okay.